Alright, so we're here on the bench with the second MRV, Alpine Mrv-1507 Amplifier. The first one had a problem that I didn't expect to see, and I opened up the second one and I found something that really boils my ass. The first one was missing a mica under the transistor. Let's just go to the test equipment cam here. You see that right there? Stuck to the side of the cabinet case on this one? That's the mica. It's just sitting in. That's the mica I was missing from the first amplifier. Wow, dude. That's messed up. I don't know, man. Somebody was some crackerjack technician. I don't know. That's scary to see stuff like that. You know, if I hindsight is 20/20, I should have opened both amplifiers and went through them, but I didn't. I picked one and went with it. If I had seen this, that would have red flag immediately. That's hilarious. So one can assume that was for the other amplifier, and this has them all. One can assume, but I'm not going to make that assumption with what I've seen so far with this. So initially everything else looks like it's here. There's some stuff unplugged. That might have been from my buddy there, but that I'm concerned he didn't mention anything about that. I would have figured he would have saw that. So yeah, I'm not entirely sure yet. So we're gonna go through this and see if all the micas are in place, all the transistors are not shorted, and bring it up slowly with some power and see if anything starts giving up the ghost or drawing more current than it should at idle. So that's where we're at with this, and we'll get ready to do that. Alright, so I'm getting ready here to go through these transistors to make sure there is no shorts. And if you don't want to watch this, that's fine, you can skip ahead. I'm not sure what other interesting stuff is going to be further in this video until I actually record it. So I'm going to leave that mica there in case my buddy's watching. It's going to stare at him till he he's probably laughing his ass off right now. Oh, nope, that's good. I'm just looking for dead shorts right now. Anything close to being shorted. That FET turned on, so that's okay. Yeah, you might hear a beep every once in a while because I'm actually turning the FETs on with the meter. So like that, I can actually shut it off, and then it won't beep again. Nope. That was turned on from the other channel. We're good there. As long as it doesn't stay shorted when you're testing these. If it starts drifting up, you can gather that it's probably okay. Without pulling them out, you really don't know for sure. I'm just looking for an initial short check. So when I plug this thing in, I just don't see it explode in my face. Alright. Now there's a dead short there, but that's actually might be right because that is the rectifier circuit. Yeah. Yeah, okay. Yeah, all four of those components are showing a short. And I will check that on the schematic to make sure. I just want to make sure nothing is going to go boom. Really quickly going through these. Really quick. I'm not even looking at the meter. All I want to know is dead short. And since I'm bringing this up on a current limited supply, I feel confident about going through these this quickly, because I can limit the current to the point where it won't damage the MOSFET if it starts to run away, or other MOSFETs. It will just knock out my supply. I know the turn on current due from the last amplifier, and if there's any serious problems, this should go into protect anyway. But there's no point in going through the hassle of hooking them all up, hooking everything up and throwing a signal at it, if it's just going to go into protect, which it still could. But at least I can eliminate possibly the MOSFETs being the issue. Good. Alright, so it appears that all the MOSFETs, oh, where'd my mascot go? I flew the coop. Anyway, oh, there it is. Oh, I really hate thermal grease. It's just crap just gets everywhere. It's on my meter leads, it's on my bench, it's just, that stuff is just horrible. It's great stuff, but it can be a pain in the ass with amplifiers. It just gets everywhere. I'm going to check these regulator transistors and make sure that those are not shorted. Not shorted. I will actually check to make sure that I have junctions on these. This was the problem with the last one. Okay, junction. Ooh, something's wrong with this side. That's a little. I'm going to throw this meter up here. I'm going to measure. Actually, let me throw the microscope on so you can actually see what the hell I'm talking about. I've already seen, I think I see a potential problem already. These are Q19 and Q20. These are the two positive and minus 15 volt regulator transistors. Well, they're in the 15 volt plus and minus regulator circuit. They're not really regulators themselves, they're just standard transistors. See if I can get my test equipment up with this. Test equipment and microscope. And I'm going to go up to the meter here. Hopefully you can see that. We're looking at this meter here. And I'm going to test the first transistor. You're going to see the junctions. Okay, that's one way. Okay, 0.6, that's your average junction. Now I'm going to go from here to here, 0.6. And I think this is an opposing component, which is a PNP. I think this one's the NPN. 0.05. That doesn't look good. 0.3. 0.05. There's just something not right with these measurements here. We should have something around 0.5, 0.6. So something is damaged in that circuit. We'll go back to this one. 0.6, 0.6, 0.2, 0.05. Yeah, something's not good. It's either probably going to be this transistor or this 16 volt Zener diode. One of the two is going to be probably shorted in some fashion, partially shorted. At this point, I'm going to check all the micas under the transistors, the insulators to the heatsink. So I'm kind of thinking that since the first one had the issue, I am going to make sure that this one does not have that issue. So at this point, we cannot power this up because I do not feel confident that this circuit is stable enough to take that power up without damaging anything any further. So I'm going to have to remove this board, this amplifier board with these regulator transistors. I keep calling them regulator transistors. They're not regulator transistors. They're regulator circuit transistors. And check out what's going on here, because I feel confident that that is probably the issue with this one. So we'll be back with that. Actually, let's just take a quick look at that Zener diode. Let's just put the diode check on here, and let's see what the Zener is for this side of the regulator circuit is. Oh, that's dead short right there. That's a dead short. That's a dead short. And the other one's hiding under this capacitor. 1.3. And it should be 0.6 or so. That way. Yep. Okay. So most likely it's this Zener 16 volt Zener diode that is given up the ghost and gone short, and is causing the effect of the short on this transistor. So I'm going to have to pull that I'm going to pull the diode and see if the short is removed from the transistor. Alright, so I have removed the shorted diode, and we're going to see Zener diode. Oh, okay, wait a minute. Let's get this up here. The diode was definitely shorted, and it looks like we still have a problem on this transistor here. That's not good. That's dead. So we weren't lucky enough to get that part back. The diode was shorted along with the transistor. That was not the case in the original, well, not the original, but the first amplifier I did. So I'm going to have to try and find a cross for that part. Hopefully I have something here that I can use. If not, then yeah, we might have to put this one on the back burner until I get another part. Alright, so I think I've got the second amplifier all sorted out. I had replaced the transistor that we had shorted and the Zener diode. So I ran it up very slowly. Well, actually, yeah, I ran it up slowly on my power supply, HP current limiting power supply. I had it limited to about 100 milliamps at first, and I brought it up, and the voltage, I brought it up a couple volts at a time, and I slowly increased the current. And actually, before I did that, I actually powered up just the power supply section, because you can separate the power supply from the amplifier board. So I brought the power supply up, and I tested the 50 volt rails, plus and minus, and they were there and everything was good. So I then powered the amplifier back down, and I connected the amplifier back up to the power supply board, and then I ran it up again very slowly because I changed those parts. And like I said, I went through and checked everything else. Everything else seemed like it wasn't shorted or nothing else was wrong. So I brought it up slowly, and no, I think she's good. She's only drawing about 1.8 amps at idle. The other amplifier has a FET issue. I'm still waiting for FETs for that. But that, I think that's the issue with that one, because it's drawing about 3 amps at idle, and I think I have one leaky FET, or partially shorting FET on that amplifier, but it still functions. So yeah, so back to this one is I brought the amplifier section up on the power supply, and yeah, let's see what we got here. I'm going to show you, let's see, I'm going to show you what I've changed here first. Alright, this is the NPN transistor I changed. I believe I specified it as a PNP before. I was incorrect about that. This is the PNP transistor for the one of the 15 volt rails, and this is the NPN transistor for the other 15 volt rail. Now you got to be very careful when changing these, because the stock component actually came with one without any metal on the back, and typically the metal of the back there is synced into the center pin on this transistor. And if I had just put this transistor on this heatsink, it probably would have done some serious damage. I actually had to put an insulator, because this one has the syncing back plane on the back of the transistor, and it's not supposed to be shorted against the case ground. So I put a little mica insulator underneath this transistor. So and I also changed this shorted zener that we had before, so that's good, and everything measures out. There's no shorts, everything's good. I brought up the power supply. I have plus and minus 16 volts on the power supply rails, so we're good there. So now it's just a matter of bringing this up and testing it on my oscilloscope to make sure we have output. I do plan on load testing this after that, but I figure that you guys don't need to see the boring part. You just want to see that it works. So I'm going to go back to the test equipment camera here and go up to the oscilloscope, bring this microscope out of the way, put the scope in here a little bit. Let's power this up. Okay, we got the power supply on. Let's plug it in. See the fan spin up. Alright, and I got my oscilloscope connected to the ground, the second ground in this amplifier, which is actually labeled on the board. And we have, that's it, we got signal. There's one channel. There's the other channel. So yeah, no, this one looks good. I think this one might have been a little bit better shape than the other one. This one, I checked all the FETs with my thermal imager, and everything seems to be running at a similar temperature. So, and it's not drawing, it's drawing, like I said, an amp and a half, 1.8 amps. You know, that's good. So once I change the FETs in the other amplifier, that should be good to go too. So let's go back here. So yeah, I hope you enjoyed this little you know, old school amplifier repair. You know, my buddy had dropped these off because he hadn't gone through them in quite a few years. So and he's a busy person, so he gave them to me to look at, and you know, he trusts me to fix his stuff. So, and no, that's good. Yeah, no, so I'm happy about this. It was a good outcome. It wasn't too serious. There was just some minor issues, and we straightened them out. I do have to find some case screws for this and put things back together. This thing was just basically just slapped in there with a few screws, and I wouldn't run this up too long without all the heatsink screws in. There's just a couple in there right now. So, but anyways, I hope you enjoyed this video, and if you like what you see, come on back, and hopefully we'll have more repairs for you, and we'll see you in the next.